Hi everyone, in this video we're going to work on one last little bit of solving. Again, my big goal in this section is just to get you really used to this inverse trig function notation and what the inverse trig functions are trying to tell you. So here I have an equation. So I am telling you that if I take the inverse sine of 3k plus 1, I get the exact same thing as if I take the inverse cosine of 2k. So if I think about what info I'm being given here, if this is getting plugged into the inverse sine, this is my y. And if this is getting into plugged into inverse cosine, this is my x. And what's really key here is that equal. So the arc length that gives me this y is equal to the arc length that gives me this x, which means I'm talking about a single point on the unit circle. So I'm somewhere on the unit circle. I don't have a great idea of where, except for the fact that inverse sine can only give me back arc lengths between negative pi over 2 and pi over 2. And inverse cosine can only give me back arc lengths between 0 and pi. So if I get the same arc length from both of them, that arc length has to be in quadrant 1. So that's about all I've got, but that's enough. Okay, so in terms of the solving, what that means is find the value of k that makes this true. So what value of k will make this x value and this y value both give you the same arc length? So really key is back to our Pythagorean theorem. We know if this point is on the unit circle, then it's x squared plus its y squared equals 1. So let me just emphasize something once again. This is absolute garbage if you're not talking about the x and y coordinates of the same point. So if I have a point here with a certain x coordinate and a point over here with a certain y coordinate and I plug it into the Pythagorean theorem, I get nothing. But if you pick out a single point on the unit circle, its x and its y squared have to sum to 1. So because of this equality, I do know that I have that. So I'm going to take my x, 2k, and I'm going to square it. I'm going to take my y, 3k plus 1, and I'm going to square it, and that should give me 1. So I'm seeing a 4k squared plus a 9k squared plus 6k plus 1 is equal to 1. The 1's are going to drop out nicely for me, so I get 9 and 4 is 13k squared plus 6k equals 0. And I can factor a k out of that. So it's looking to me like k equals 0 would be a solution. That factor 0 makes the whole thing 0. Or k equals negative 6/13, which would make this one 0. And as always, you can do the scratch work if it's not easy for you to see that. Set this other factor equal to 0, subtract 6, and divide by 13. So do as much work as you need to. If you're wanting to err on the little side, do as little work as you think you can get away with without me not being able to tell what steps you did. Okay, so here's the thing to remember. Whenever we're solving an equation and any part of it can have domain restrictions, we have to worry about extraneous solutions. So we want to think about this. It happens actually a lot with the inverse trig functions because they've been so heavily restricted. The function actually is so heavily restricted that it's really easy to get outside of the range of good solutions. So we can think about this. If k is equal to 0, then I get inverse sine of 1. So if my y coordinate is 1, that's going to give me back an arc length of pi over 2. So that's promising so far because it is in that 0 to pi over 2 where the two functions both work. If I put the 0 in here, I get inverse cosine of 0, which is also going to give me pi over 2. So 0 seems great. Without calculators, this might seem a little terrible, but it is actually doable. So if I plug the negative 6/13 in here, multiply it by 3, I'm going to get negative 18/13, and then I need to add 1, which is 13/13. So I'm at negative 5/13. Okay, so I say my y value is negative 5/13, and I'm concerned already because I've said that the only way this can work is if the arc lengths I get out are between 0 and pi over 2. Otherwise, sine and cosine, inverse sine and inverse cosine, are not going to give me the same thing. So I'm already pretty sure I'm in trouble, but if we want, we can check a little further. If we plug this in negative 6/13, we get negative 12/13. So this is saying my x value is negative 12/13. So there is a point on the unit circle that has a y value negative 5/13 and an x value negative 12/13, but it's not a point that's going to work for this equation because inverse cosine is going to give me the arc length that lands me here since I'm forced to the top of the circle, and inverse sine is going to give me the arc length that lands me here since I'm forced to the right hand side of the circle. So this is not a good solution. Okay, I've got one more. So once again, if you're feeling comfortable, great to pause and try this one out on your own. And in fact, I'll show you another little trick to starting this problem. It ends up with the exact same equation, but some people like it better. So you could turn this into a lot more of a problem like the last round, I think, that we were working on, the composition ones. So you can rearrange either way. Say I want to get rid of the inverse sine, so I could take sine of both sides, and I'd end up with this statement. This does not in any way change my equation or my picture, but if that's easier for you to get the information out of, you can use it. So what I see when I write it this way is if this is getting plugged into inverse cosine, it's an x. If this is coming out of sine, it's a y. And again, the thing that's really key, so looking up here, inverse cosine is going to output the arc length that gets me this x value. Inverse sine is going to output the arc length that gives me this y value. And this equation is claiming that they're the same arc length, which means that x and that y belong to the same point, to a single point. Seeing that down here, I'm trying to remember what I was even just talking through. We were talking through, yeah, that it has to be the same. So down here, I say, here's an x value, find the arc length. When you give that arc length to sine, it'll give you a y value. So going from here to here makes it hopefully clear that we're talking about the same point when we talk about this x and this y. So we'll say that x squared, which is 2w minus 1 squared, plus y squared is equal to 1. And we can multiply that out. So 4w squared minus 4w plus 1 plus w squared over 9 is equal to 1. The 1's drop out again, so this is kind of nice. At least we got decent algebra. You can deal with a fraction however you want to. I think I'm going to multiply everything by 9 just to clear it. So over here is 0 anyway, so it doesn't make a big difference. But I will get 9 times 4. I'll get 36w squared. Minus 36w plus a w squared. The 9's are gone. So I have 37w squared minus 36w equals 0. I'm going to factor out my w. Oh, this orange pen's getting tired. And I'll be left with 37w minus 36, which means w could be 0 from this first factor, or w could be 36 over 37. Okay, so there are my two possibilities, and I have to check out the same thing as before. Will those actually meet up at a point in quadrant 1 so that both inverse cosine and inverse sine are happy with it? So if w equals 0, I get inverse cosine of negative 1, which is going to put me, let's make a different color, over here. Okay, so my x coordinate is negative 1. So inverse cosine is going to try and tell me my arc length is pi. So this is not looking good. Not over here on my quadrant 1 chunk. If I give, what was I doing? 0. 0 to sine, I get inverse sine of 0. So y coordinate of 0, it will give me this one. So notice again, there is a point that has an x coordinate -1 and a y coordinate 0. That does exist on the unit circle, but it doesn't exist in the realm of inverse sine and inverse cosine both. Inverse cosine is fine getting over here, but inverse sine can never get over here. So this time the 0 is bad. Let's see if the 36, 37s, if we can kind of struggle through that. Okay, so if we plug it in here, so we're getting 2 times this. So 2 times 36, 60, 72. So we have 72 over 37. And then we're subtracting 1, which is 37 over 37. 37, 47, 57, 67. So 35 over 37. Okay, so we're getting inverse cosine of 35 over 37, which is really close to the right-hand side of the circle. So that's the x value I'm supposed to have. So right now, I'm really gunning for this top point. Oh, in fact, I'm being silly right now. We're on the inverse cosine, so it has to be this top point because inverse cosine would always give me a point on the top of the circle. If I go to inverse sine, so I take my 36 over 37 and I divide it by 3, which is the same as multiplying by 1/3. I get 12 over 37. So I have this small positive y value, and that's looking good. That does put me in quadrant 1, so the x and the y both can match up with an arc length in quadrant 1. So this is my keeper. All right, thanks for watching.